Hello students, now we are going to a new particular session, Objective Type Question Level 1 of the chapter Unit and Measurement, Class 11 Physics by me, Sapna Soni. So, let's begin with the first question. The ratio of SI unit of Universal Gravitational Constant to CGS unit is option 10 to the power 3, 10 to the power minus 3, 10 to the power 6, 10 to the power minus 5. The correct answer for this question is 10 to the power 3. Let us see the solution of this question. So, what we have just going to do, we just put the value of SI unit. Students, I hope you remember in the previous lectures what we did. We know if the quantities are equal, that means N1 U1 is equals to N2 U2. Okay, so we know that the value of N1 by N2 is equals to U1 by U2. Okay, so the thing is that only SI unit ratio we have to ask. So unit, if I'm just taking SI, kg meter second, okay, in this form. So kg, we can say meter cube by per kg per second square for the universal gravitational constant. So m minus 1 L3 T minus 2 divided by, in the CGS, m minus 1 L3 T minus 2. But the thing is that here the kg is converted into the gram, or we can do convert like here the CGS unit. So we have to convert this that kg into gram. So after conversion, the value which comes, that is 10 to the power 3. Second question we have, if unit in two system of measurements are in the ratio 2:3, the ratio of the units of angular momentum in those two systems is 2:3, 9:4, 1:1, 4:9. So let us move with the solution part. We know m1 by m2 is equals to L1 by L2 is equals to T1 by T2. And as we know, dimensional formula for angular momentum, L is equals to ml to T minus 1. Put all these value here and we got this value 4:9. According to that, the correct answer is 4:9. Next question we have, if the unit of length and force each quadrupled energy increased to 8 times, 10 times, 16 times, 2 times. So students, as we take the mean of a quadruple, this is a 4 times. So energy into force into length. Okay, we can say a torque also, force into displacement perpendicular, or we can take as a verb, force into displacement also. All these are form of energies. So we just put this value like a 4F, because here the F is converted into the 4F and L into the 4L. So this will be 16 times. I hope you understand. Next question we have, when the velocity of light is taken as unit of velocity and year as a unit of time, then unit of length is, we have these options. Move with the solution part. We know that V is equals to L by T. Velocity is equals to distance upon time, and L is equals to V into T. So the velocity V is equals to 3 × 10 to the power 8. This is the velocity of a light actually in vacuum. So we just put all these value like 365 days in a year, 24 hours, 60 minutes and 60 seconds. We just solved this particular term and got this value 9.310 to the power 15 meter. Next question we have, the power of a motor is 200 watt. If the unit of length is half, that of mass is double, and that of a time is also double, then the power of the motor in the new system is 3200 watt, 3200 new unit, 12.5 new unit, 12.5 watt. So let's firstly see the questions. We have given the value of power. Then after, length. Mass is double and time is also double. So new power we have to calculate. Let us see the solution. N1 U1 is equals to N2 U2. N1 is equals to 200. M1 is equals to M. N2 is equals to, we just have to calculate, M to 2 meter. So we just put all these value. As few terms already given, U1, ML2 T minus 3, L1 L and T1 T, L2 L by 4 and L2 2 times of T. Okay, so we just put all these value together and got this value 3200 new units. Okay, we can solve this manner also, students. Like, so how we can solve this particular terms? Like, we know N1 or N2 is equals to N1. Directly I am doing M1 by M2 to the power A and L1. Directly we are putting the power also. So M1 by M2 to the power A, that means 1. L1 by L2 to the power B, that means here it is given 2, and T1 by T2 by T2 to the power minus 3. As in the question is given M1 M and this will be 2M. Next this will be half, so L and then L by 2. Next T and then T by 2. So what we receive from here, N2, this is a 1 by 2, this is a 2 square and this is a 8. So we can say this is a 200, this is a 2, this is a 8. And after that, after solving, we get the value 3200 new unit. I hope you understand, student. Next question we have. The density of a material in CH system is 8 gram per centimeter cube. In a system of unit in which unit of length is 5 centimeter, unit of mass is 20 gram, the density of the material is in the new unit. We have to calculate. So 0.08, 50, 40, 0.04. The question solution is, we know that the density is equals to mass per unit volume. Mass per unit volume. And if I am just writing the dimensional formula of volume, this is a L cube, and mass, so this is a M. Apply N1U1, that is a quantity equality. N1U1 is equals to N2U2. N1 is equals to 8 and N2 we have to calculate. M1 1, M2 20, L1 1, L2 5. We just put this value in this equation, like N1, as we know this is a 8, U1 is already given, U1 is a given unit in terms of like this M, and here only L3, so M1 by M2, L1 by L2, here this is a power minus 3 is equals to N2 over there. Okay, so if I'm just putting the value of M1, this is a 1, now M2 20, L1 1, L2 5, power minus 3, that comes 8 into 1 by 20 into 5 cube is equals to N2. Okay, so we can easily put this value like this and receive the answer N2 is equals to 50. Okay, 25 here we get and 2 here, 25 and 2 20, 50. Okay, the next question which we have, if the unit of force were 10 Newton, that the power were 1 megawatt and that of time were 1 millisecond, then the unit of length would be 1 meter, 100 meter, 10 to the power 3 meter, 10 to the power minus 2 meter. So Move with the solution part. As we know that power is equals to force into velocity. If you want to get want to know this answer, like how this value will become, so power is equals to work done per unit time, and work done is equals to force into displacement, and displacement divided by time gives velocity. So this comes power is equals to force into velocity. Now we just put all these value and get the result 100 meter. I hope you understand, students. Next we have a question. The addition of two physical quantities is possible only if both have different dimensions, two dimensions, same magnitudes. So, conceptual part is that the addition of a two physical quantities is possible if they have a same dimensions. Next question we have, which of the following can be expressed for the speed to transverse wave? Lambda represents wavelength. So here we have these options. Let us see the solution of this question. Verifying using dimensional formula. So what we are going to do, see, which of the following can express speed to a transverse wave? For speed, g is what? In meter per second square. Okay, and I'm just putting the value of lambda, which is a meter. So this will becomes meter square by second square to the root. That means meter per second. And this is the unit actually of the speed. Clear? We can do with the dimensions also. This is the mt minus 2. Again 2 pi is the thing, and next m. So we got m2t minus 2 with power half, or we get mt minus 1, which is the unit of dimensional formula for speed. Other, if you just want to check, that comes like mt minus 2 by m by L. Sorry, this will be LT. This will be LT. By mistake, I'll just written M. This is a meter per second. Okay, this is a L. So here LT minus 2, and this will be a L. So this comes with the unit like this. T minus 1. So this is a unit, actually the frequency. This is the term gives frequency dimensional formula. So like this you can check, and our option is the second option is the correct. The position of the particle moving along x-axis with uniform acceleration depends on time. According to the equation, x is equals to at square minus vt cube, dimensional formula of A and B are. So we have these options. Let's moving with the solution part. According to the principle of homogeneity, these two equations can be equals, okay, if their dimensions are equal. So we have to calculate the dimension of A and B, and x is the position of the particle moving along x-axis. Okay. So again, x is a what? If I'm just taking like x is equals to at square. Clear? So dimensional formula for A is x by t power a by t square. Yes, this will be not minus a by t square, x by t square. So x I'm just taking as a position, that means length. So this will be LT minus 2. And all the options, only one single option is correct, that is second one. So we can put this similar way. According to that, second option is correct. We just choose like this type of a question is if they came in the examination. So what you have to do, you just check once only, okay, and then just mark it out. Next question we have, y is equals to a sine omega x by v minus k pi. This is an expression for a wave motion. Dimensions of x and k were omega and v are angular velocity and linear velocity respectively. So we have to calculate the value of dimensional formula for X and K. Let us move with the solution part. Using the principle again homogeneity. So omega K by pi, which gives all the values 0. So we just get the value L and T. Next question we have, if S is equals to A plus BT plus CT square plus D by T plus E by F minus T square, where S is the displacement and T is the time. So dimensional formula of F we have to calculate. Simple question is we have an options. There is no need for the option, students. Like S, again you applied principle of homogeneity. So this equation will be balanced to this if they are dimensionally correct. Okay. Now S is equals to E by F minus T square. Clear? So for that scenario, what you have to calculate? S is F minus T square is equals to E. So E by S is equals to F minus T square. Okay. Or we can say F is equals to T square plus E by S. So the unit of F is actually T, that means T square. Okay, I hope you understand. Here is a little bit trick which you have to do. You just take this term and this complete term and try to resolve this term. Okay, try to solve this particular each and every method, and you got the final answer easily. Next question we have, the displacement of the particle moving along X is given by X is equals to this values A long BT plus CT square plus D, where T is the time. Then the dimensional formula for C are, so we got this values. Okay, again, like CT square is equals to constant. So C is actually T minus 2. For that scenario, the correct option is option 3. Now moving on the next question. The expression S is equals to A by B 1 minus e to the power minus bt is dimensionally true. The dimensional formula of A and B are respectively if the S is the displacement at any instant. We have an options LT and T, L minus 1T and T minus 1, LT minus 1 and T minus 1, LT minus 1 and T. Let's move on the solution part. We know Bt is equals to constant. So, B is equals to T to the power minus 1 or T minus 1. S is equals to A by B. So, A is equals to S into B. S is a displacement over there and B is, as we know, T minus 1. So, finally, A T minus 1 and B L T minus 1. So, the correct answer for this question is third one. Next question we have, the coefficient of viscosity of liquid eta, we are pronunciating this term eta, is given by eta is equals to pi Pr to the power 4 8 Bl. Okay, so we have to calculate this value where the pressure is V, L length of the capillary tube, R radius of the tube, and dimensional formula which we have to calculate. So this is the LQ, L3T minus 1, L2T and LTQ. We have to calculate what is actually V is. Now substituting the dimensional formula and solve for the V. V is equals to the rate of flow, so which is the volume by time, and this will be L3 by t, which is L3 t minus 1. So this is an important question for your students board also, like for the examination purpose as well as for the NEET and JEE, as well as many competition level exam like a UPPCS, like these kind of exams. These questions are generally asking. So be prepared for that. Next question we have dimensional analysis of the relation energy to the power n is equals to pressure difference to the power 3 by 2 volume power 3 by 2 gives the value of n as 3, 2, 3 by 2, 1 by 2. Solution which we have, substitute the dimensional formula and solve for the n. So we know that energy ml to t minus 2 power n, m l minus 1 t minus 2 power 3 by 2 and L3 which is a volume power 3 by 2 is there. We just solve this particular term and got the value of n. So from here you can see little bit solution m to the power n, l minus 2n and t minus 2n. So m 3 by 2, l we can calculate from here and t again minus 3. m to the power n, l to the power 2n and t to the power minus 2n, which we got the values m 3 by 2, l3 t minus 3. So from here we can calculate easily the value of n is actually what? 3 by 2. So from here we got the answer 3 by 2 and of course in option this is the present in option 3. Next question we have 17th question. In a van der Waals equation E plus A by B square B minus B gives R T, the dimensions of A by B are same as we have to calculate. Now moving with the option pressure, volume, energy, temperature. Students, let's move with the solution part. By the principle of homogeneity, we can see that P is equals to A by V square and A is equals to PV square. So, A by V is equals to PV square by V. That means PV, which is equals to energy. P means pressure and V means volume. How we can relate this term energy? We can relate this term by the dimensional formula. Okay. So pressure is equals to what? Force per unit area, which is ml t minus 2 area L2 and volume L3. So if we just divide this particular term, we got ml2 t minus 2, which is the dimensional formula for energy. Okay. And pressure, as I tell you, that this is ml minus 1 t minus 2, volume L3, temperature we can use K or theta, and similarly energy which we got ml to t minus 2. So we got this value of energy. Here students, so the correct answer for this question is energy. I hope you understand. Next question we have, the number of particles crossing unit area perpendicular to x-axis in a unit time is given by n is equals to minus t, n2 minus n1 divided by x2 minus x1, where n1 and n2 are numbers of a particle per unit volume, x1 and x2 are distance, the dimensions of d are m0l t3, m0l2 t minus 4, m0l t minus 2, m0l2 t minus 1. Students, let's move with the solution part. So we know that n is equals to 1 by 80. A is what over there? A is simply amplitude for that. So we got the relation L minus 2. A is amplitude for the area. Okay, so we are just taking area. And T is time, as we know. T is time. Clear? So from here we can calculate the value of n, which is L minus 2 T minus 1. N1 is equals to N2, which is a 1 by V, and V is a volume over there. So this unit is L minus V. X1 is equals to X2, which is L1. Substituting all these equations and solving the value of a dimension D, we just put all these values and get the value of a D, which we got M0L2 T minus 1. From the option, we can say the correct option is 4th. I hope you understand, students. Moving ahead with the next question. Velocity of a sound in a medium is given by a to the power half d to the power minus half, where d is the density of the medium. Then a represents what? So, elastic constant, energy, volume, or a compressibility. Students, we know that V is equals to a to the power 1 by 2 and d to the power minus 1 by 2. That means what we written over there, a is equals to a by d. Here we written this one. If I'm just correlating all these things with their dimensions, so as you can see over there, velocity Lt minus 1, a, m to the power a, l to the power b, t to the power c to the power half, because we don't know what is this actually. D ml minus 3, because this is density. After substituting all these values and after a little bit solvation part, we got the value of actually m, which is m a by 2 minus half. So what we are just doing, we just correlating or comparing this term. So a by 2 minus 1 by 2 is equals to 0. So a by 2 is equals to 1 by 2, and we relate the value that a is equals to what? 1 actually. Similarly, we do with this b by 2 plus 3 by 2 is equals to 1 actually. So b by 2 is equals to 1 minus 3 by 2, which we got b by 2 is equals to minus of half. B is equals to minus 1. Clear? Similarly, we will just do with the C also and got the value of A is equals to 1. B, as I solved, minus 1. Similarly, for a C, minus 2 will save. The steps, are you understanding, students? Okay, so now the value of A, B, C, we just put this one and we got the relation. This is actually T minus 2. So at the last, this is the actually value of elastic constant. Okay, L minus 1, T minus 2, elastic constant. So from this, we can say the correct option is option 1, which is the elastic constant. Moving ahead, 20th question. If J is angular momentum and E is kinetic energy, then J square by E has the dimensions of moment of inertia, power, angular velocity, impulse. So let's move with the solution part. J square by E. By their dimensions, we can say the value is J square by E comes ml2, which is actually the value of a moment of inertia. According to this, the correct option is a 1. Students, if you not remember the formula of moment of inertia, that is I is equals to mr square. So m is the mass and r is radius of that rotatory body. Okay. We can say rotatory body if you not want to consider. So radius between the two bodies and from their axis. Next question. The distance traveled by a particle in nth second is Sn is equals to u plus a by 2 2n minus 1, where u is the velocity and a is the acceleration. The equation is dimensionally true, dimensionally false, numerically may be true or false. 1 and 3 are correct. Let us see the solution of this question. So according to the dimension, as you can see, the LHS dimension is completely differ for individual dimensions of each term. of RSS. And according to the principle of homogeneity, what we know that equations are dimensionally correct only when the individual terms of the individual terms dimension must be equals to the LHS particular quantities dimension. So as we saw here, the dimensions are differ from the LHS. So this is a dimensionally false. Okay. So what they not obeying? Principle of homogeneity. According to that, this is the dimensionally false equation. Okay. But if I'm just talking about is this correct equation, not dimensionally. So yes, this is a correct equation, but dimensionally, this is a false. Understood? Next, when a wave transfers a medium, the displacement of the particle located at x at time t is given by y is equals to a sine bt minus cx, where a, b and c are constant of the wave. The dimensions of b are the same as those of wave velocity, amplitude, wavelength, wave frequency. The correct answer for this question is, as we know, bt is equals to m0 l0 t0. So b is equals to t minus 1, and t minus 1 is the actually unit of frequency or the dimension of frequency. So the correct answer is option is 4. Next question we have, when a wave transfers a medium, the displacement of the particle at x at time t is given by y is equals to a sine bt minus cx, where a, b and c are constants of the wave. The dimensions of b by c are the same as those of wave velocity, wavelength, wave amplitude, and wave frequency. So we have to ask that b by c dimensions. Let us see the solution of this question. Cx is equals to m0 l0 t0 because Cx is a constant. Now C is equals to L minus 1 because x is showing the displacement over here. So Cx is equals to constant. Constant's dimensions always m0 l0 or t0, or we can say constant have a no dimension. That's why we are writing in this form. Clear? And C, as we know, here this will be x. So m0, l0 and t0 with x dimension, which is L. So we can write over there m0, l minus 1, t0 also, or simply we can write l minus 1. This is the dimension for this, and because we have to ask about C also, so Bt is equals to constant, students. Again, B dimension is what? T minus 1. So if somebody will be asked, like if the question will be asked B by C, so B is what? T minus 1 and C is L minus 1, or we can write as a LT minus 1, which is a velocity. So B by C is showing what? Wave velocity. I hope you understand, student. Moving ahead with the next question. If pressure is equals to F, A, E, B, T, C, where F, E and T are force, energy and surface tension, the values of A, B and C are 1, minus 1, 1, minus 1, 1, 1, minus 1, minus 1, 1, and the 1, 1, minus 1. So let us see the solution of this question. As the question asks, like pressure is equals to the F, A, E, B and T, C. So we just put the dimensions of each terms. Now what we are going to do? Relate the terms M here and M here. Similarly with the L, T, okay, we are doing. So what we can write over there? M to the power A plus B and plus C, like this. Okay. And similarly with the L and T. Now A plus B, after comparison, what we can see, A plus B is equals to what? 1. And A minus 2B plus 0 is equals to minus 1. 2A minus 2A minus 2B minus C is equals to minus 1. So from here, like from this particular term, we can easily calculate the value of A in terms of a B, and by that value we can put in any equation and get the value of A, B and C like this. So after solving, we get A is equals to 1, B minus 1 and C 1. For more details like how I did complete term, minus A from second equation, minus A is equals to minus 1 minus 2B, or we can put as A is equals to 2B plus 1. Clear? This I got the equation in terms of a B. Second equation I also have to do convert in the terms of a B only. So from this value, if I'm just going through the back side, so as you can see, like one step more. Yes, minus 2A minus 2B minus 2C is equals to minus 1. So what I'm gonna do, from here, as you can see, minus 2A minus 2B and minus 2C is equals to minus 1. So if I'm just common A plus B plus C over there is equals to minus 1, and from here A plus B plus C is equals to 1 by 2 from this. Okay, again we can put this value of A over here, and we got the value of or B we can put also, or A plus B also we can put. So in this equation or here, A is equals to what? 1 minus B minus C. So I'm just put this equation here also. So this comes 1 minus B minus C plus B plus C. From here we can't get anything, so I'm getting back. Okay, so students, like this value, what we can get, I'm just putting this value over here. Similarly, you have to do like B plus 2B plus 1 plus B plus C is equals to half. So I received the value like 3B plus, if I just transfer this value over here, this will be converted minus. So 3B plus C is equals to minus half. Now we have the value of like B and C and again B. So we got the value of a B also, which is get minus 1. Okay. Next question, we can move further. If the vibration frequency of atom in a crystal depends on the atomic mass small m, the atomic spacing small r, and compressibility capital C, then it is proportional to 1 by m square, second under root r, third C, fourth none of these. So if we just move through the solution part, as we know n is directly proportional to m, a, r, b and c, c. So substituting all these part and we get the value of a C, which is a m minus 1 L1 T2, which is under root R. Next question we have, if the velocity of light, which is C, universal gravitational constant G and Planck constant H are the fundamental quantities in a system of measurement, then dimensional formula for mass is C half G minus 1 by 2 and H half. We have similarly these kind of options. Let's move with the solution part, students. m proportional to c to the power a, g to the power b, and b to the power c. Substituting all these value over here and get the value of a g, h. So according to that, the correct option is a 1. Next question which I have, the mass small m of largest stone that can be moved by flowing river depends upon the velocity v of the water, density d of the water, and acceleration due to gravity small g. Then m is directly proportional to v to the power 6, or these kind of like options we have given: m proportional to under root v, m proportional to g, and m proportional to 1 by d square. Let's move with the solution part. So here, m directly proportional to the v to the power a, d to the power b, g to the power c. Now we just put the dimensional formula. So velocity's dimension is lt minus 1, density ml minus 3, glt minus 2. Now we can find the value of ABC from here, which is get the value of m, which is direct proportional to v to the power 6. Next question we have, if the velocity of light, capital C, universal gravitational constant G, Planck constant, I think this is the same question. I think so. No, this is the now time dimensional formula for time. Earlier it was for something else. So what we do, same procedure we applied for that and get the result. This question is a very interesting question. Like under root 3.0 is 1.732, 1.7, 1.73 or 1.8. Students, this is a not under root 3 only. This is under root 3.0 is. So the solution that no number of the significant figures are 2. So answer must be expressed into the 2 significant figures only. Clear? For that 1.7 is the correct answer. Again, if the value is like this root 3, so the significant figure if they ask, so that you can write up as a 1.732. But here the point is mentioned over there. So because of it that this point digit, we just apply the significant figure. Okay, rules over there. The number of a significant figure in this 6, 5, 3 or 2. What we know from the knowledge, like after the point, if the zeros are there, so zeros that will be what? Counted. So according to that, the correct answer is 5. Next question we have, the mass of the box is 2.3 kg. Two marbles of the masses measured as 2.15 gram and 12.48 gram are added to it. Total mass of the box is. So we have 3 things. What? First box and 2 marbles. These 3 things we have. We have to calculate the total mass of the box. So this we have given the options. Again, this is the applied here the significant rule. So in the addition or subtraction, the final result should retain only that many decimal places that are a number, at least decimal places are there. So as you can see that there will be 1 and there will be 2 and there will be 2. So what we can gonna to do, just add these things and we just write up after adding up to 2 digit only. Okay, and then we can convert into the kg system simply. So according to that, we have the answer 2.32. At the last, as you can see over there, we have only 2 digits according to the significant system rule. Next question we have, the accuracy in the measurement of a diameter of a hydrogen atom as 1.06 10 to the power minus 10 meter is. Let us see the solution. Accuracy now removed from our syllabus. So we are just taking one question for the Neet purpose. Delta D by D is the finding the diameter accuracy. So after the solution, we got the answer 1 by 106 times. So 1 by 106 times means the correct answer is option 3. Next question we have, the length of the rod is measured as 31.52 centimeter. Graduations on the scale are up to 1 millimeter, 0.01 millimeter, 0.1 millimeter, 0.02 millimeter. The correct answer for this question is that 0.01 centimeter is the least count, so the correct answer is 0.1 millimeter. Next, the accuracy in the measurement of the speed of a light 3.00. Again, this is a significant figure. If I just count, there will be three significant figures are there. 10 to the power 6 meter per second is. Now move with the solution part. The significant with the accuracy, we know that delta C by C into 100. So after the solution part, we got the answer 1 by 3%. Next question we have, with due to regard of a significant figure, the value of a 46.7 minus 10.04 is. Firstly, what you have to do, like see the significant figure. Accordingly, you have to give the answer. So least number of the digit of the decimal will be minus 1. For that, the answer will be 36.66. And when you are doing the round of a 675, so the preceding digit is a minus 1. According to this, the correct answer is 36.7, which is option 1. A physical quantity which is represented by x is equals to MA, LB and TC in the percentage error in the measurement are alpha percent, beta percent and gamma percent. Then the maximum percentage error is. Now let us see the solution of this question. So for that we know delta x by x into 100 is equals to a times delta m into m divided by m into 100. So what we are gonna to do students, देखो यहाँ पे क्या करना है हमें, delta x by x into 100, okay, and a if the power is there, as you see here is a power, so what we are doing, just multiplying here and we just again relate this term. This is a error or this is a true value. For percentage, I'm just doing 100 multiply. If the value asks in the fraction, so change the value, the change meant which got the error and by m. So if that again power is there, so power we are multiplying over here, power. According to that, we have like alpha a, because this is a percentage, m percentage is alpha percent, b percent is a beta percent and c percent is a c like gamma percent. So if we just solve, we got the answer. This is a very easy question. The density of a mercury is CGS system is 13.6 gram per centimeter cube. Its value in SI system is, we have an options are. Now let us see the solution of this question. So 1 gram per centimeter cube is given 10 to the power 3 kg per meter cube. And D is given as the density is already given 13.6 10 to the power minus 3 gram per centimeter cube. So when we put this value and get the result 13600, that is 13,600 kilogram per meter cube. According to this, the third option is the right answer. Next question, if the unit of length and time be changed from meter and second to 100 meter and 15 second respectively, then the ratio of which the velocity and acceleration change are. Now let's move with the solution part. So L1 is equals to 1 centimeter, T1 1 second, L2 100 and T2 50 second. Now velocity is what? N1 by N2 is equals to U1 by U2. So N1 is a given over there. That is 100 into T15 minus 1. So we just put all these value N2 by N1. We receive 1:2. So acceleration, this is the case for velocity, and the same acceleration, what we get, N2 by N1, 25:1. So according to that, the correct option is 3. Next question we have, if the velocity, if the unit of a length is double and the mass is a quadrupled, the unit of density is double, half, quadrupled, not affected. Now the solution is density is m by L cube, d is equals to 4m by 2L cube. That means this comes half. Now here I just want to introduce the things like for more elaboration. This is the change in density. As in the question given, mass is a quadruple, that is a 4 times. Okay. And length is actually double. So 4m by 2, that means 2 cube, okay, L cube. So what it comes, 4 by 8 m L cube. This is the value actually of a density of initial. This is a change in, and after dividing, this is a comes 1 by 2. So final density is a half of the original one. Now I hope you understand, student, how the half comes. Next question we have, if the unit of force, length and time each are doubled, then the unit of mass becomes. Now let us see the solution. Now force unit is, dimensions are mLT minus 2. Now mass is Ft2 by L. New mass 2F, 2T and 2L. So that will be 4 times. Next question which we have, the value of acceleration due to gravity at a place is 980 centimeter per second square. Its value in kilometer per minute square is. So now see with the solution part, 1 centimeter by 1 second square is equals to gives 60 into 60 10 to the power minus 5. So that will be kilometer per minute square, 3600 10 to the power minus 5. So after a little bit more solution, we got the value 35.28 kilometer per minute square. According to this, the second option are the right answer. If you have any question or doubt, student, you may ask in the chat session, in the comment box if you have. Next question we have, the electric resistance of a conductor is 18 ohm. If the unit of mass and length are doubled and the unit of a time and electric current are also doubled, then electric resistance of a conductor in new system is 72, 4.5, 18 and 9. So the solution is drift, like the dimensional formula of resistance this. We put these values and get this result. Next question we have, if the unit of force is 2 Newton, that of the length is 4 meter and that of velocity is 6 meter per second, the unit of mass is. So now move with the solution part. Like F is equals to mv by t. So m is equals to F into t by v. We put this value and get the result 2 by 9. And we know the unit of mass is actually kg. So what we want actually the number we want. Next question we have, if the unit of a length is doubled, the unit of a time is half and the unit of force is a quadrupled, the unit of a power would change by the factor 1 by 4, 16, 1 by 16 and 8. So the correct answer for this question is P is equals to FL by T. So P1 by P2 is equals to F1 by F2 into L1 by L2, T2 by T1. So after the solution, we got the value for P1 by P2 is equals to 1 by 16. So P2 is equals to 16 times P1. According to that, the second option is the right one answer. Next question, we have according to the Bernoulli's for the incompressible liquid under streamline flow. Condition is a P plus half dV square plus H dg is equals to constant, where P is equals to pressure, D density, V velocity and H height. The equation is dimensionally correct, dimensionally wrong, cannot be predictor, and none of these. So if I'm just moving with the solution part, this is the dimension of P. I'm just putting each and every value. So as you can see, the dimensions are exactly as same as the pressure. So they are dimensionally correct. Now, the next question is, the critical velocity V of a body depends on the coefficient of viscosity eta, the density d and the radius of the drop. If k is dimensionless constant, then V is equals to, we have these options. Now, the solution is V directly proportional to the eta to the power a, d to the power b and r to the power c. Now, after putting the dimensions of each and every terms, we can calculate the value of a, b and c. So after solving the value of a, b, c, we got the equation third. Next question we have, if the depression d at the end of a loaded bar is a given, d is equals to mgl cube by 3yi, where this is a capital I, which is a moment of inertia, student. So here m is the mass, L is the length, Y is the Young modulus, then I is the dimensional formula. So keep in mind you have to give the answer dimensional formula of I in dimensionally. So I is equals to mg L cube by yd. After solving, you get the value of L4. So what is the I over there? The quantity name is dash. You have to search that what quantity is actually, and the dimensions are L4. According to this, the correct answer is 4th. Next question we have, the dimensionally correct formula is, the correct answer is S is equals to ut minus at square. Next, in van der Waals equation, RT the dimensions of BR. So the dimension of BR we can calculate, like V is equals to V, which is L3. According to this, the correct option is the 4th. Next, if the displacement of a y of a particle is y is equals to a sine pt plus qx, then the dimensions of a p are, the dimensions of a q are this, the dimensions of a p by q are this, and the dimensions of a pq are this. Again, if this type of a question came, students, so you have to check each and every part. Because if the equations like dimensions of p, dimension of a p and dimension of a q, dimension of a q, so you have to calculate only p and q, but here you have to calculate be careful for this type of a question. So solution, what we have, pt is equals to ml0 t0 l0, because this is a constant term. Now from here we can calculate the value for p, which is t minus 1, also q, which is l minus 1. So p by q is equals to what? L t minus 1. From here we can get the answer, like third one is the right answer. Next question which we have, in eta is equals to a by b log bx plus c. This is dimensionally true. Then here eta is the coefficient of viscosity and x is the distance. So c is dimensionless, b has a dimension of a minus 1 in length. The dimensional formula of a is a ml minus 2t minus 1. All the above are true. The correct answer for this question is Bx is equals to constant. So from here we can already calculate that B is what? M minus 1 L minus 2 T minus 1. According to this, that all options are correct. C is firstly constant and B dimensions, as you can see, like dimensions is a minus 1 of a length, as you can see, and the dimensional formula for A is what we receive, that is a M1 L minus 2 T minus 1. So all these correct answers. I hope you students understand we did 51 questions. Later we do more, but till now, take care everyone and do practice. Thank you for watching this video.